Hi everybody, so it's week 5 of Math It Up, and the topic this week is simultaneous linear equations, which I'm sure everybody is already aware of considering that we cover this in freshman math. And if you're a freshman and you still haven't covered this, that's okay because you will eventually. So there are 6 practice packets available this week. Again, they're up in the Education Resource Center where Miss Lyons works. So without further ado, we're going to begin the video. These videos address any questions you may have about the topic we're covering this week. And basically I take practice problems from each of the practice packets and put them up on the board to hopefully give you an understanding. Alright, so let's begin. Alright, so this is one practice problem from packet number 1. So anytime you're presented with a simultaneous linear equation, the strategy is to try to cancel out one of the variables. And it doesn't matter which variable you begin with, because you're going to end up solving for both of them by the end. So, to begin, I'm just going to cancel out x because I think that'll be easier. So what I need to do is multiply this second equation by 3. So I'm just going to rewrite the first one. 3x plus 5y is equal to 50. And so I have to multiply each by 3. So I'm going to get negative 3x minus 6y is equal to negative 57. Alright, so now you'll notice that if I add these two equations together, the 3x's will cancel out. Then 5 plus negative 6 is negative y, and that's equal to 50 plus negative 57, which is equal to negative 7. So then I take this negative over, again, like we learned in week 1, and we get y equals 7. Alright, so we found one variable. So now all we need to do is take this variable and plug it in back to any one of these original equations. So I'm just going to plug it into here because I think that would be easier. So we get negative x minus 2y equals negative 19. I always like to rewrite the equation just so it's organized. So we'll substitute 7 for y. So we got negative x minus 2 times 7 is equal to negative 19. So we'll get negative x minus 14 equals negative 19. We're trying to isolate x, so we'll add 14 to both sides of the equation. So negative x equals negative 19 plus 14, which is equal to negative 5. And then finally, this becomes x is equal to 5. So that's it. You've solved for both of the unknowns. If you want to go back and plug these two unknowns into one of the original equations, that's another way to check if it's correct. So if we see here, if we do 3 times 5, that's 15, plus 5 times 7, 35. 35 plus 15 is 50, alright? So we got that checked. And then if we plug it into the second equation, we have negative 5 minus 14. That's equal to negative 19. So we got our two variables, and we checked to make sure that they're correct.